Hello, class. Welcome back. So, we've started talking about integrals now, and so we're talking about indefinite integrals. And so in the last video, we did the indefinite integral of x squared, and we saw, hey, if you take the indefinite integral of x squared, then you get x cubed over 3 plus c. So I wanted to give you the general rule today for what happens when you integrate a power of x. And then I want to do a few examples of it just to make sure that we're all on the same page about how this ends up working. Okay, so remember, before we do the power rule for integrals, remember the power rule for derivatives was just saying, hey, what happens if you take the derivative of x to the n? Well, if you take the derivative of x to the n, then you get n times x to the n minus 1. Okay, so that's the thing we're giving the analogous version of. And so I want to say, hey, what happens if you take the integral of x to the n? Okay. And so normally what you get is x to the n plus 1 divided by n plus 1 plus c. In fact, you get that as long as n is not exactly minus 1. And so if you think about last time when we did the integral of x squared, we got x cubed over 3 plus c. That's exactly what happens here. If n is minus 1, then this is 1 over x. And so we're asking, what's a function whose derivative is 1 over x? Well, if you think through your brain, you'll come up with natural log of x. And for reasons we won't get into too carefully for the moment, you actually are going to say the natural log of absolute value of x plus c when you're actually asked to integrate n equal minus 1. Okay, so let's do some examples. So let's take the integral of 4x squared plus 6x minus 5. So just like derivatives, we can do this piece by piece. So that is, we're separately going to consider the 4x squared, the 6x, and the minus 5. And not only that, we can also basically ignore the constant part at the beginning of each of these and just carry that forward. So when I go to take the integral of 4x squared, I'm going to get 4 times x cubed over 3. Okay. And all I did there, again, was to say, okay, well, I'm going to carry the 4 forward, and then the x squared, when I integrate it, I'm going to get x cubed over 3 plus c, but I'm only going to put the plus c at the end. Okay. Plus, and now this is a 6x to the first power. So when I integrate that, I'm going to get 6 times x squared over 2. And then minus, and then this minus 5, you might not realize it, but it's really a minus 5x to the 0th. And so the integral of x to the 0th is going to be x to the 1 over 1. And then I have to remember my plus c. Now, of course, we probably want to simplify that a bit. I definitely want to simplify that a bit. And to simplify that, we just have to collect all of our terms here. So I'm going to write this. This is 4x cubed over 3 plus, and then that 6 halves is 3, so just plus 3x squared minus 5x plus c. Okay, so that will be our answer to the integral of 4x squared plus 6x minus 5. Just like the power rule for derivatives, this is a little bit more flexible than it appears at first. So I want to do something like, okay, what's the integral of 6 over x cubed dx? And so I have to remember, hey, this 6 over x cubed, I can write the over x cubed as being a 6x to the minus 3. Okay, so I'm rewriting the x cubed in the denominator as a power of x as an x to the minus 3. And now I can apply the power rule. So when I do apply the power rule, I'm going to get 6 times x to the, and I have to add 1 to minus 3. So when I add 1 to minus 3, I get minus 2 divided by minus 2 plus c. And so when I do that, that is going to be minus 3 over x squared plus c. That will be our answer. Now, if you sort of think through other things that you know that we've often written as powers, you could take something like the integral of 3 root x minus 7 dx. And so this radical, I can rewrite this as 3 times x to the 1/2 power minus 7 dx. And now that I've done that, I can use the power rule here. So this is going to be 3 times x to, and so now I have to add 1 to a half. So when I add 1 to a half, that'll give me 3 halves. And now I have to divide by also by 3 halves. Minus, and then remember I think of 7 as 7 times x to the 0. So this will be 7x to the 1 over 1 plus c. And I can go ahead and clean all of this up a bit. So this 3 halves in the denominator, that's the same as multiplying by 2/3. Okay, and so when I multiply by 2/3 like that, the 3's are going to cancel, and I'm going to get 2x to the 3 halves minus 7x plus c, and that will be my answer for this integral. Okay. Last up for this video, I want to note that sometimes things will only cooperate with you if you really work at it. Okay, so if I've got this here, at first it looks like there's no way I'm going to be able to do this because this is a fraction. And please remember, I have definitely not given you a quotient rule for integrals. In fact, it's going to turn out there's not a quotient rule for integrals. But if I'm willing to use some algebra, I can actually do this because I can rewrite this thing I'm asked to integrate as the integral of 2x over x squared minus 3 over x squared dx. And so this 2x over x squared, that's the same thing as 2 over x dx, minus 3 over x squared dx. And I can, of course, rewrite that in terms of powers. So this is a 2x to the minus 1 is 3x to the minus 2 dx. And now here is where you need to remember that when we gave the power rule, there was a specific call out in the power rule for what happens if this power of x that you're looking at is exactly the minus first power. Because if this power is exactly the minus first power, you need to remember that you're going to get something with a natural log in it. Now, if you didn't remember that, please note that what would happen is you would be saying, okay, it's x to the 0th divided by 0. And probably you should see something has gone wrong when you find yourself giving an answer where you're dividing by 0. Okay, so here, in particular, we're going to get 2 times the natural log of the absolute value of x minus 3 times x to the minus first power divided by minus 1 plus c. Don't forget the plus c. And that's equal to 2 times the natural log of the absolute value of x. And then this is minus a minus, so it's plus 3 over x plus c. And so that will be our answer. All right. I'm going to wrap up there for today. Until next time, be well.